Okay, hello guys. Welcome back to my physics class. So you are in Form 5 now. So what am I going to do today is we are going to discuss on the first chapter, Forces and Motion 2 for the first part. Okay, now Forces and Motion, why is it for part 2? Because you learned it when you were in Form 4 last year. I do not know how much you remember about that topic, but this year, Forces and Motion 2, it will go deeper compared to last year. Last year, whatever that you learned about forces and motion is actually just very basic topic and very basic idea on what is force and what is a motion. Now, for forces and motion, normally we're going to study in linear motion, okay? But then you're not going to learn a lot about projectile. You are not going to do a projectile motion in Form 5. Okay, but there are things that you have to understand how to resolve the forces and so on and so forth. Now, I'm just going to speak it like this. Even though I speak like this, maybe you don't understand what I'm saying, but never mind, we'll just go into it. Okay, so why is it that importance? Why is it that it is important for you to learn this chapter? First thing is, if any one of you want to become an engineers and designers, I know some of you want to become engineers and some of you maybe want to go into interior designers of structures, or you need to understand and apply the fundamental concepts of physics such as resultant force, resolution of forces in equilibrium when designing a unique structure. Means like, for example, there are a lot of very unique buildings. For example, IOI Taipei buildings, okay? IOI Taipei buildings. How does the building withstand earthquakes? There are a lot of things that you have to understand that. So it is all in physics. Let's say you have enough ideas on the resultant force, resolution of forces and equilibrium. Actually, you can give ideas in how to make sure the buildings are safe for certain natural disaster. Okay, so that's why you need to understand on this topic. Okay, these aspects are important to guarantee the integrity of the building structure. All right, before I move on, now let us just watch a very simple video about this topic.
The Langkawi Sky Bridge on Gunung Mat Cincang is an astonishing feat of engineering that allows visitors to literally take a walk in the sky. At 700 meters above sea level, the Sky Bridge is one of the world's highest single support bridges and offers visitors 360-degree views of the Langkawi Archipelago, the Andaman Sea, and southern Thailand. Endorsed by the Travel and Leisure magazine as one of the world's most spectacular bridge designs, the structure curves respectfully with the terrain, a breathtaking example of man and nature working in harmonious accord. Access to the Sky Bridge is via an exhilarating 15-minute, 42-degree cable car journey. The cable car and Sky Bridge do not operate when the weather is unfavorable, particularly during high winds. When you arrive at the top, you'll understand why.
Okay, now it is fascinating, right, on how Malaysia itself, our country itself, we have this kind of very unique buildings, very unique structure, bridge. Okay, we have a lot of very unique structure and buildings that really needs a high understanding about how to build it for our own safety. Okay, for example, uh, do you ever ask about how they built Jambatan Pulau Pinang that connected between the island to the mainland? So there are a lot of things that you have to ponder about. Okay, so for today, I'm not going into deeper about how was it built and how it's built and how the structure was. Okay, so I'm going to focus on the basic topic about resultant force, resolution force in equilibrium. So let me go next. Okay, so the topics that you're going to learn in this chapter is resultant force, resolutions of force, it's not resolution of help, sorry, resolution of force, forces in equilibrium, and resultant force. So let's go on. Now, what is resultant force? Okay, let's see here. What is the resultant force? Resultant force is the single force that represents the vector sum of two or more forces acting on an object. Now, if you look at these pictures, this is a tug war, right? This is a pertandingan tarik tali. So you will see this in sports day. Okay, I know we were not even in the sports day for 2 years, but now you are going into the next level. We're going into the endemic, so you might probably have sports day. Now that's a different story. Now let's go focus here. So what is the resultant force? Resultant force is the single force that represents the vector of sum of two or more forces acting on an object. For example, when tarik tali, right? If let's say you have two teams that pull the tali to the other side. So whichever the side go on, whichever the side have a greater forces, it will move to that side, right? So that's what you understand about. So that will become the resultant force. Resultant force is the force in the end, the result of the forces. Okay, the single force that represent the vector sum. Vector sum means the direction of two or more forces acting on the object. Okay, when two forces of the same magnitude acting in the opposite direction are applied on a stationary object, the object remain at rest. So that is what you have. Then, if the two opposing forces have different magnitudes, the object will move in the direction of a large force, a larger forces. Okay, so it's just logic. Just that the thing is, you don't like to memorize the definition. Please understand. Please remember the definitions of the resultant force. Now, I give you three situations. The first situation, I have this participant A and participant B. Both of them have equal amount of force. So when they have equal forces, what happens is both of them will remain at stationary. They will not move to the left or to the right because both of their forces are the same. So that's why the resultant force is zero. Okay, the resultant force is zero. Next one. If let's say the forces, the final result, the final force, the resultant force is to the right, you can see that FB, okay, the participant B is actually exerted more forces than participant A. So that's why you see in mathematics sense, FA is less than FB. Okay, so FB is greater than FA. So that's why the resultant force is to the right. Okay, this is just logic as long as you can understand how the forces go on. So FA for participant A will have a greater forces to participant B if the resultant force is going to the left. If we look at this diagram itself, you see here, the resultant force of this person, participant A, is actually greater than the participant B. So that's why the whole thing will be moving to the left. Okay, so that's the resultant force. Now, so the first part, after you know the direction, that one just now, the three situation is just for you to understand the concept of the resultant force. Now, what happened if let's say you are asked to determine the resultant force? What do I mean by determine? It means to find out the value. What is the value for the resultant force? Now, today I'm going to only show you about, I think, this situation 1 and situation 2. I'm not going to share with you situation 3 first and 4 because situation 3 and 4 is kind of hard. You need to resolve the forces, but for today I'm going to only talk about the things that is in one dimension, which is to the left and to the right, which is one dimension. So to the left and to the right. So if you look at situation A, two forces acting on an object in the same direction. So add Newton to the right, 6 Newton to the right. So what do you have? 8 plus 6, you will have 16. Sorry, 8 plus 6, you will have 14 Newton. So the resultant force is equals to 14 Newton. Next one, for situation 2, two forces acting on the object in the opposite direction. Now, normally in this kind of question, we are going to consider to the right, positive, to the left, negative. So 8 Newton minus 6 Newton, you'll have 2 Newton. So the object will be moving 2 Newton to the right. I repeat again. 8 Newton is positive, 6 Newton is negative. So 8 minus 6, you will have 2 Newton. So 2 Newton to the right. Normally, it will follow whichever the forces that is greater. Okay, so sometimes in exam, you are asked to answer the question. When you answer the question, please make sure that you manage to answer not only the value, you are able to answer the direction also. Because you learned this one last year. What is force? What is force? You have to remember what is force. And then is force a vector or scalar quantity? You have to remember that. Okay, so I'm not going to tell you what is force because I'm going to ask you tomorrow in my class. Okay, so I'm going to stop here. See you tomorrow.